Good morning, students. So today we're going to solve question 7 from GATE CSE 2025 set 1. The question states that the diagram, the line QR and ST, this line QR and your ST are parallel to each other, right? This part I've written here in the given section, right? As I've written this part, let's cut this line because that part has been analyzed by us, right? That part of the question is done. Now let's go to the second sentence. The sentence says that the shortest distance between the two lines is half the shortest distance between the point P and line QR. So this is a statement that we will have to break down and understand very clearly, right? So the shortest distance, let's read it again with a bit of analysis, right? The shortest distance between these two lines is, first of all, what is the meaning of shortest distance between these two lines? Which lines are they referring to, right? Now the concept of shortest distance when applied to lines is kind of very interesting. Suppose that the two lines are not parallel, then if the shortest distance between them is actually 0, because there is going to be a point of intersection at some point on the Cartesian plane, right? At some point in the plane those two lines are going to intersect because they are not parallel. So the concept of shortest distance only applies if the lines are parallel, right? And what are the only parallel lines provided to us in the question? This ST and QR, right? So they are talking about that shortest distance between these two parallel lines, that is going to be this thing, right? Shortest distance, as you must have known, between lines means that the shortest distance representing line must be perpendicular to both these parallel lines, right? That is a fundamental meaning of shortest distance, right? As you can clearly observe that if a line were not to be perpendicular to both of them, in that situation the length would be greater than the length of the perpendicular, right? So that is something which is we do not want. We want the perpendicular distance. That is the part which they are referring to over here. Then they are saying that the shortest distance of these two lines is half of what? The shortest distance between the point P, this point, and this line, right? The shortest distance between the point P and the line QR, right? Now the concept of shortest distance from a point P, suppose that this is a point and this is your line, right? So shortest distance from a point to a line is the perpendicular that is drawn from that point on the line, right? As you can clearly observe, any distance which is not the perpendicular is going to be greater than the perpendicular, right? The shortest distance is given by the perpendicular, right? So from P, if we were to draw the perpendicular on QR like this, then that is going to give the shortest distance from P to QR, right? And this thing is going to be perpendicular to line QR. This thing is going to be perpendicular to line QR, and because ST is parallel to QR and this line is intersecting both these parallel lines, the angle made with the perpendicular, this particular line with this ST which is parallel to this line, is also going to be perpendicular. Why? Because a line which is intersecting on parallel lines makes equal angles with them. This is even true with this line PQ. It is basically intersecting both of the parallel lines, so the angle that they make is similar, right? This is a fundamental concept of geometry. This was taught in 9th and 10th classes. You must know about this. If you are forgotten this, let me remind you of that this is a property which exists, right? With this information with us, right, we can then read the line again and understand it better. The shortest distance between two lines, right, between these two lines is half the shortest distance between the point P and the line QR, right? So the shortest distance between these parallel lines is given by this distance because it is perpendicular to both of them, right? And this is given as half to this whole line, meaning that this length is same as this length, right? This length is same as this length. That is part we can directly deduce because this is half of the whole length. So this part represents the other half, right? So with that understanding, we can say that yes, this these are of same length, and this is a valid interpretation of this whole information, right? We can deduce further whichever way we want after analyzing what the question actually demands from us, but for now we have actually distilled out whatever information they have provided to us in this line, right? This particular line has been completely analyzed and its information has been distilled out. I have written that information over here, that the shortest distance, that is the perpendicular distance from ST and QR, is equals to half of the distance. This distance is half of this whole thing. I have written it over here in the given section of the question, right? Now let's read what the question actually demands. The question demands that what is the ratio of area of the triangle PST, right? This triangle PST to the area of the trapezium PSRT, PQRT, right? What am I even saying, man? SQRT, right? So this is a trapezoid and this is the triangle. So what is the ratio of the area of, if the numerator had this area and the denominator had this particular area, right? That is what we are trying to find over here. So I write it over here also separately, right? Now the thing is, how can you attack the whole problem, right? So there is a concept in geometry that we were taught in 9th and 10th classes, which is known as similarity, right? Similarity concept, right? So if I will give a link to a web page that will describe similarity in the description also, but I think that you must know that what similarity is, right? If you are not if you have completely forgotten it, you can go and read the link. It's a random website which is explaining it, or you can find it on the Google or yourself also. But the basic concept is that similar figures are basically the same figures, but the size is different, right? Similar basically means exact same figure, just the size is different, right? So for triangles, the condition for similarity is, one of the conditions actually is double angle being same, both two angles being same, right? So as you can see, for this triangle PST, the S angle is same to the angle Q for PQR, and this angle P is common, right? From this we have that two angles, right? These angle being same because of these line being parallel and this angle being common. So double A condition is met. So we can say that PST is similar to triangle PQR, right? This we can say. Obviously, if this understanding is not very clear, because it's very completely analytical and deductive, but because they have given to us that the figure is representative, right? If this figure were to be schematic, then we would have to imagine our own figure and understand how the whole thing is working. But because the figure itself is representative, so we can at least for our understanding over here, we can apply our tools from this computer, right? Basically the computer graphics we can apply on this, right? So suppose that this triangle, I have drawn a triangle which is of same size of this triangle, right? PST. Let's put this into perspective so that you have better grasp on what I'm trying to explain, right? This triangle is of same size as PST. Now from computer point of view, I am increasing its size linearly, both in vertical and in horizontal direction, right? So from this, if I were to increase the size linearly like this, right, and then I place it over here, as you can see, as you can completely see, this triangle is exactly, this PST is exactly the same triangle that PQR is, but the size was different, right? So they are similar even from a qualitative point of view, right? You can, I think that you would be able to grasp what I'm trying to talk about here, right? As these triangles are similar, right? Similar triangles have the thing being present, they are exactly the same. This is just the size is different, right? So their size has been increased, right? If PST were to be increased both horizontally and vertically in equal proportion, then it would give you PQR, right? And we know that the height of that PST triangle is half of the height of PQR, as can be observed from the information that we have distilled from the question, right? Because this length is the height of PST, right? And this length is the height of PQR, right? So you can see the height difference is twice. So this previous triangle PST, if it were to be increased twice, both vertically and horizontally, it will give you PQR, right? So suppose that the original height was taken as h, right? As the original, not original, basically the height of the bigger triangle was taken as h naught, and the smaller triangle were to be taken as h, then h by h naught, right? H naught represents your bigger triangle, big, right? That is going to give you 1 by 2. And also if, for example, the base, right, base or any side, if any side, this side to the whole this side were to be taken, then that would also have this ratio, right? Because base is going to come in handy later. I'm also writing it over here so that our analysis can be used further. You will notice what I'm trying to what this information is going to be helpful in the later part of this video, right? So let's write that also, that the base of the smaller triangle by the bigger triangle is also equals to your 1 by 2, right? This part this both information is very important. Remember that we have deduced it and how we have deduced it. It's very important that you understand this information. Now let's move further. What we exactly need to find? This thing, right? So let's work on that, because understanding the question well is solving the answer, a half part of solving the answer, right? So let's try to break that portion, right? So this is what we are trying to find, right? The area of triangle PST by the area of the trapezoid SQRT, right? Now this trapezoid, the area that this trapezoid hold is basically the area of this bigger triangle minus the smaller triangle area, right? So let's write it like that, right? I've written it like this. Now if I were to divide the numerator and the denominator by PST, right, dividing the numerator and denominator by PST, I get this particular expression, right? So as you can see, the exact expression that I need to find out is the area of triangle PQR by area of triangle PST. Now if as soon as this comes, the student makes a mistake over here, that he thinks that as we are both of the triangles are similar, right, and it's a similar relationship exists, and we have already found out that 1 by 2 relationship as present over here, they are directly going to substitute 1 by 2 over here, and that is going to give them a wrong answer, right? They are going to substitute that they're going to substitute 2 over here, and they will find 1 minus 2 minus 1, that is going to give them 1. So they're going to mark 1, and that is a wrong answer. Why it is wrong answer? Because area does not only have one single component, it has two components, right? Both the x-axis, this is the y-axis and this is the x-axis, are present. So whatever ratio you would have found for linear transformations, that is the height that we have found, its square must be taken, right? I will not do it like that. I will directly apply the values, the ratio for the values that we have reduced above, and then from that find out, right? Okay, so the area for the triangle is given by the formula half into height into base, right? So the ratio of the area for PQR, that is the bigger triangle, to the smaller triangle is given by this thing, right? The half part is common in both, so we can cut that part, cut this part, right? And now we're going to have to find for this, but as you can remember, just now I have taken this information and written it on the first page, right? On the first page, right? And this is the information, and the similar part, this part is also present. Now as you can see, the big B naught is twice of B, right? And h naught is twice of h. Keep that information in your head and then come here, right? H naught represents the height of the bigger triangle, that's why it is double of your h, and b naught represents the base of the bigger triangle, so it is also twice, right? So let's just cut this and cut this, we get 2 over here, cut this and cut this, we get another 2 over here, and that is going to give you 4, right? And we can apply this 4 over here to get our answer, and that is going to be 1 by 4 minus 1, and that is going to give us 1 by 3. Let's see which of the options satisfy this 1 by 3, right? So the first option, A option, satisfies this 1 by 3 condition, hence that is our answer. This was a question that required practice in aptitude, and all these concepts that I talked about must be thoroughly in your mind, even if all of it, we are all humans, right? So all of the concepts may not come to your mind exactly, but how those concepts are applied, that part must be very clear in your mind, right? And that will only come when you do practice on this. And I would suggest that in every week that you're preparing, put out some time separate for aptitude type questions, because aptitude requires practice, separate kind of practice, and you require it on a daily basis, right? So kind of do it that way. And I hope that you must have learned something from this video. Some of your concepts must have been revised from this video, and I would say that you liked this video, right? If you like the video, like and subscribe, and have a very good day. Thanks, man.